Aside from square tiles, hexagons are one of the most popular grid systems for video games. It's often a popular choice because of its unique art style. Getting started, however, can be a bit more complex than spawning cubes next to each other. Hello and welcome back to another video game development video. While my other video games are slowly brewing in the background, to avoid spoilers, I thought it would be fun to show you some of the other projects I'm working on. I've been developing this hexagon terrain system for a while now, and it's starting to become a bit bigger of a project, which I intend to show you in another video. But for now, I thought it would be worth showing the basic version of a hexagon terrain generation system. Let's jump into it. Alrighty, so all of my code is completely free and you can find the link to this website down in the description. Now, when you click the link, you'll open up to this Git repository where you can clone the code. I'm going to download the zip file, and in Finder here, this also works on Windows as well as Mac. You can unzip the file and import it directly into your Unity project. So I'm simply just going to drag the file in here and we can get started with the hexagon terrain generation. So in this file, you'll see there are a couple things. There's one script, there's 4 materials, and there's 1 hexagon. I've pre-made the hexagon file for you, so it's nice and easy. I'm going to create 2 empty game objects. The first one I'm going to call the HexGen system. So that's basically just the place where the script is going to go on. And then I'm going to create a second object, which I'm going to be calling the hex holder, which is going to hold all of our hexagons. Now, in this HexGen script, you can see there is a lot of different things going on. So first of all, let's just drag in all of the empty fields. So our hexagon, of course, will go in here. Our hex parent will be our hex holder. And then we can drag in all of the materials. Now, I've pre-made some materials for you, but of course, you can pick whatever colors you want, which best fits the style of your game. So once all of those fields are filled in, it is as simple as that. You can go ahead and click play, and instantly you will start to see terrain being generated. Now, we've got lots of different parameters that we can mess around here, but most of the settings are pretty good right from the get-go. So you can simply change this one right here, the seed, to get different results of what your product will look like. For example, if I just type in a random number and then hit this update mesh button, you'll see that it will automatically update it. Now, I'll go through and explain what each one of these things are so that you know and can tweak parameters if you so desire. And there's also a randomize button, which will randomize most of them for you. But for the most part, if you're just looking for terrain generation, this is it. That's all you need to do. The chunk size is the amount of hexagons that are spawned in a grid. So for example, if it is a much lower number, and I hit update mesh, you can see there's a much smaller chunk. And likewise, if there's a much higher number, there is a much larger chunk being spawned. I like to have it somewhere around 100 or so because that is plenty enough mesh for me. The height multiplier is how tall do you want your terrain to be. Now, right away, you may notice that there are holes and everything is turned to stone. And that's because you have different heights set for different material types. We'll get into that. Let's just bring the height multiplier down to something like 5 for now. And you can see a bit more of the terrain come to shape. The sand up to this height and the grass up to this height all determine in which levels you want to set to grass and to sand. So if I say I can have grass up to 4, of course, then I'll have grass up to 4. And if I say I have sand up to 2, you guessed it, sand will go up to 2. The water level is the level in which water will come up to. You can enable this button right here called snapping heights. Now, right now, all of our grids are freely going at random heights, but if I enable snapping, it will always jump the grid to the nearest one whole section upwards. If I extend the bottoms, it will make it so that all of the bottoms go both up and down, which means if I have a really high height multiplier enabled and I extend the bottoms, it will fill in all of those gaps for me so that my terrain can be more normal. If I disable snapping here, you can see a bit more smooth of what some of this terrain might actually look like. Now, of course, 68 is quite a large number anyways. The highest you would probably go would be maybe something like 15.
kind of depending on your terrain, of course. But you can see now that I've got this extend bottoms checked, it will fill in all of those gaps for me. It also raises the height a little bit, but if I snap, you can see especially those little gaps that come through. They're quite easy to see here. So when I'm snapping, I often try to extend the bottoms as well. And of course, this randomize check button will just randomize all those values for you. Note that when you are randomizing, it is actually changing how your terrain is being generated, not just what the terrain looks like. So it is changing all of these values, not just the seed. So once you find a specific way of how tall or how high your water is or stuff like that, I would suggest trying to keep the randomize button unchecked and just changing your seed instead. One other thing to note here is that the scale parameter determines how large our noise is, or basically how big our islands are going to be. So if I scale this up, you can see it's the exact same texture, it's just enlarging it. So you can have more detail or less detail depending on how you want your game to be. Really, the tool is as simple as that. You can go ahead and go into more detail. If you want to watch the next part of the video, I'll explain some of the code to see how it works. Here we are in the code, and it may seem a bit complicated at first, but it's actually quite simple. There's only about 200 lines of code here, and I'll try to explain the primary important things that you'll need to know for building your own system here. So first things first, you can see that there are 5 methods in this class. So we've got the set hex type, the calculate the heights, the generate meshes, and both the start and the update function. Now the start and update function simply just call these other functions if we want to use them, but those are not as important to us right now. What we're going to focus on are these other 3 down below. So in the generate mesh function, we are calling each of the directions of our chunk size for both the X and the Z direction. And for each of the X and Z directions, we're going to calculate the heights for that specific location. For example, if you have an X1 and a Y1, you'll pass those parameters in to find that height. Now, once we get that height passed into our calculate heights function, we're going to take both of those coordinates and pass in the increased value. Now, the increased value is important because our hexes are not a perfect grid. There is an offset required for each of our hexes to go up 1 and over whatever our set value is for our hex size. In this case, it is a 1.732. Now that's important. It depends on how big your hexagons actually are. That is a specific value for my hexagons, but it's an important thing to make a note of. Each hexagon will move north 1.5 and over 1.732. And those are the offsets that we can apply to each hexagon that we are spawning. So once we add our increased values to our numbers, we can take those coordinates and add our scaling and our seed to find out what our exact coordinate is for this function. And we can find that coordinate in our Perlin noise function. Now this is the function that actually determines where all of our heights are going to be. Perlin noise is pre-built into Unity, which is super nice because we can just pass in 2 coordinates and get a result back to us. So that is awesome. Of course, there is some extra code down below for if I am snapping heights or if I am not, but this is all just different ways of basically saying the same thing. What we're saying is we are going to instantiate or spawn a hexagon at a certain position and a certain rotation. I apply a name to the hexagon and give the hexagon a parent so that the hierarchy is more organized. And if the hexagon is not divisible by 2, essentially if it is in an odd row, then I will apply the offset position that we spoke about earlier, the X increase value. Once I have spawned my hexagon, I'm going to set the hexagon type based on how high it is and where it is located. In this function, I check to see if it is water, if it is sand, if it is grass, or if it is rock. And based on those parameters, I simply change the color to the appropriate color. If you want, you can also add a tag here, which then you can use for something like walk sounds. But that's pretty much it for this video. Thanks so much for watching. Here you can see a little bit of a gameplay of this system that I've been implementing in a game project I've been working on. And so hopefully you'll be able to create some pretty cool things too. Thanks so much for watching. See you in the next one.